Hi, Dr. Wang here. This is a training video for Plasmid Editor 5. In this assignment, we are going to use the SAPIO platform to first identify the location of the primers on plasmid PMSH2 mutant. After identifying this, we are going to simulate a PCR reaction on SAPIO. This assignment uses the same sequence file as Plasmid Editor 4. So I have those files already downloaded on my computer. So the next thing is to create a new module. And I'm simply going to first drop my PMSH2 sequence. Make sure to rename it. Then drop the mutant sequence. Rename it. And also rename this module. All right, so now all the sequences are ready. The next step is to identify the primers. So I'm simply going to copy the sequence for the first primer. And then the question asks you to locate this primer on PMSH2 mutant. All right, so with this sequence visible here, I'm going to go to annotation PCR primer. And then this is primer 1. Paste the primer sequence in here, and I'm going to search. So you can see the software has located the primer, and this is in the forward direction. So we can tell that this is in the forward direction because here we can see the two strands of DNA. The top strand is in the forward direction, the bottom strand is in the reverse direction. So this primer sequence ATTTT is identical to the sequence on the top strand. So this is in the forward direction. I'm going to click create. All right, so the next step is to do the same thing for the second primer. Copy primer sequence, coming back to annotation PCR primer, and this is primer 2. I'm going to paste the sequence here and then search. So we can see that again, a match was identified, and this is on the top strand as well, TTCTT. Okay, so create. All right, so we're going to repeat the step for primer 3. Go to annotation, PCR primer, name this as primer 3. Paste the sequence in the search box and then search. So this time, no match was identified. All right, so here I'm going to go to orientation and then change this to reverse direction, right? So I'm just going to paste this sequence here one more time to make sure that I have pasted the identical sequence for primer 3. Now I'm going to search under the reverse direction. This time, well, a match was identified. So let's look at what this actually looks like on the double-stranded DNA molecule. The primer sequence is GATGA. So we can see that it's identical to the bottom strand, right? It's right here, GATGA. So the primer is actually on the bottom strand or in the reverse direction. So now I'm going to click create. So you can see the visual display is that this primer is going to the left. So it's in the reverse direction. The forward direction is going to the right. For a circular DNA, the forward direction is clockwise and the reverse direction is counterclockwise. All right, now I'm going to do this for the last primer, right? So here coming to primer 4, right? So paste the sequence right here, search for the forward, and as you can see, no match was identified. So this is actually a telltale sign that this is on the reverse direction. So I'm going to change the orientation, paste the primer, and then search. So now, again, a match was identified. So this is TGCA. So as you can see here, TGCA. So it's on the bottom strand, right? So create this primer. We can see that this is going in the reverse direction. So coming back to this question, we can see that it's asking for which primer pair will allow you to amplify a region that contains the mutation. So to answer this question, we have to know where is the mutation. So for this, we actually need to align PMSH2 and PMSH2 mutant sequence. So we have done this before, right? So we need the alignment function. So I'm going to go to analysis sequence alignment. This is going to open a new tab. So this time I'm simply going to choose the entire DNA sequence. And then down here, make sure that we are lining up DNA sequences and then run analysis. So this is going to line up the two DNA sequences. And there is a single mutation in the PMSH2 mutant sequence that differs from the wild type. So what I'm going to do is to keep scrolling until, right, so I'm doing this fairly quickly, but you should be doing this fairly slowly until you see that single differences. And right, so let's keep on going. Oh, okay, it's right here. Right, so we can see that the DNA sequence in the wild type PMSH2 is a T, while in the mutant T has been mutated to G. And this position is 3,800. This is where the mutation is. So knowing this, I'm going to come back and then actually make this or mark this locations, right? So I know that this location, this mutation is located at this position. 3800. So with this nucleotide highlighted, so we can actually see that 388, right? So here I have already selected this nucleotide. I'm going to go to annotation and add this as a feature. I'm simply going to call this a mutation. And this is going to highlight that single nucleotide, add feature. All right, so now we have basically located all the primers and the mutation. So now we can see their relative location, right? So it's actually right here. The circular version is a little hard to see. Oh, actually, I need to first hide all the restriction site. This is going to clear up the graphic view to make it a bit easier to see. This is in the circular format. So I'm actually going to make it a linear format so that I can zoom in onto this region so we can see this a little bit easy. So we can see mutation is located right here. So we have a forward primer that's going towards the right. We have a reverse primer, right? So we can see the direction of this primer is going to the left, right? So this primer is going to the left. And primer 4 is also going to the left. Primer 1 is going to the right. And the mutation is right here. So we are looking for two primers that run towards each other. All right, so one running towards the left, one running towards the left, and they're going to meet right in the middle. And in this region, we'll also expect the mutation to be located right there in the middle. So I have drawn an illustration here. Mutation is located right here, and that's the relative position of the 4 primers. We can see that primer 2 and primer 4 are running towards each other, right? So they're going to amplify a PCR product starting with primer 2 and ending with primer 4, right? So this is the actual PCR product that will be amplified during PCR if you use primer 2 and 4. And we can see mutation is right in the middle of this PCR product. So this is the answer for question 1. And we can see here that none of the other pair is going to work, right? So this is the only pair where the 2 primer run towards each other with mutation right in the middle. All right, so with that, we are going to move on to the second question. So the second question asks you to use the correct pair from the first question to perform a PCR reaction. We can actually simulate this reaction on Sapio. All right, so let me just make it back to a circular sequence and then display sequence. All right. So this function is actually right here. There is a button for primers. So I'm going to click on this button. Here are all the primers. So I know that the pair that we have identified is primer 2 and primer 4. So I can simply remove primer 3 and primer 1 from the list. So now this makes it a bit easier for me to select both primer 2 and 4. When you select a pair of primers, you can see this button is now enabled. So I'm going to click on this button called PCR product. So now I'm going to close this. So we can see that the PCR product simulated PCR reaction. So this is the sequence for the actual PCR product. And then this is the length, right? So how many base pair is in this PCR product? And this number is the answer for question number 2.